All right, the next thing that you're going to do is choose the level of significance, and remember that that is alpha. And alpha, I said, is a big deal because alpha is going to help you find your cutoff scores. Remember I said your test statistic has to be bigger than your cutoff score in order to be significant? So alpha is going to help us to figure out what those cutoff scores are. But technically speaking, alpha is the probability of making a type 1 error. So if I were to ask you for a definition, this is how you define it. What I've explained up here is why it's a big deal. It's a big deal because it helps us to establish the cutoff score. But that doesn't tell you what alpha is. So a definition of alpha is that it is the probability of making a type 1 error, which means it's the probability of rejecting HO when HO is true. It's the probability of that false positive. And the reason why she's all freaked out here is because we typically do not want to make a type 1 error. Researchers do not want to mislead other researchers. We don't want to publish a study, saying, hey, we've got significant effects, something is going on here, when in fact, there's a high probability that it's a type 1 error. We just don't want to do that. So before we go ahead and publish a study, we are going to look at what would be our probability of making a type 1 error. If we go ahead and reject HO, what is the probability that we're actually wrong about that? We should have kept HO. So you see why alpha is a big deal. Like we just don't want to make a type 1 error, right, in the literature, because that can have profound effects. So what we do is we usually say, okay, I will only reject HO if the probability of a type 1 error is less than 5% or less than 1%. So let me explain that. We have to make a decision, right? We're going to use a statistical test, and we're going to make a decision based on that test. Do we reject HO or not reject HO? Well, the guideline that we're going to establish for ourselves is one of these two. Okay, so if we're using 0.05 as our alpha, that's the probability of making a type 1 error if we reject HO. What is the probability of making a type 1 error if we don't reject HO? I'm going to let you think about that for just a second. What is the probability of making a type 1 error if we retain HO? The answer is 0. The only way you can make a type 1 error is if you reject HO, by definition. You can go back and review a couple of slides if you forgot that, right? You can look at that square with the 4 outcomes. In order for you to have any chance of making a type 1 error, you must first reject HO. So when we look at a definition for alpha and we say alpha is 0.05, the way we have to phrase our definition is to say that the probability of making a type 1 error is 0.05 if we were to reject HO. Okay, now that may be acceptable to you. You might be saying, oh, so if I go ahead and reject HO, I only have a 5% chance of being wrong? That doesn't sound so bad. 5%, I can live with that. But other people, like maybe her, she might say, oh my gosh, are you kidding me? That is way too high. I am only going to reject HO if the probability of making a type 1 error is less than 1%. So in other words, if I reject HO, my risk of a type 1 error is 0.01 or less. Because remember, this is just the decimal format of this. Same thing, 5% is 0.05 in decimal format. Okay? Don't worry, we're going to be going over this many different times, many different ways. Okay? All right, how does alpha affect our decision to reject or retain HO? Why is it so important for this decision? Well, here it is kind of summed up for you. We will decide to reject HO only reject HO when there is less than a 5% or 1% chance that we will be making a type 1 error. All right, so it depends. If you want to be like a high baller, you know, one of those risky people, then you can say, look, I'm going to reject HO as long as I have less than a 5% chance of making a type 1 error. But maybe you're super conservative and you're going to say, nope, I'm only going to reject HO if my risk of a type 1 error is less than 1%. Do you know what business uses? What would you say? Are business people the gamblers or are they ultra conservative? Well, I'll let you in on a little secret, at least with respect to hypothesis testing. They are the high-risk gamblers. They will reject HO as long as the risk of a type 1 error is less than 10%. So that's gambling. That's some pretty high stakes here, okay? But that's what they're willing to do. In the behavioral sciences like psychology, we use either 5% or 1%. Now, what happens if you determine that the probability of a type 1 error is greater than 5% or 1%? Remember, we're saying it's greater than this if you reject HO. It's greater than 5% or 1%. So what do? Don't reject HO. Retain HO. If you think that this risk is too high, then don't reject it. Keep HO. Say your results are not significant. And then you don't have to worry about making a type 1 error. Remember, you can only make a type 1 error if you reject HO. So if the risk of a type 1 error is simply too high, then you retain HO and you move on. All right, it's pretty simple. Don't take the risk. So you're kind of like doing this cost-benefit analysis. Now, here's a little FYI for you. If you go up to a very strict, staunch statistician, they do not like you to say retain HO. Even though that's what you're technically doing, they don't like it when you use that word. They prefer you say fail to reject HO. Now, what's the difference? Well, in their mind, they see a difference because they say if you fail to reject it, you're only saying you fail to reject it this time. Maybe next time you will reject it. And they think that if you say retain HO, that's too deterministic. That's too final, rather. It's like saying, I'm going to keep HO forever and ever and ever. Now, most psychologists, I don't think, are going to get this nitpicky. But just so you know, if you are speaking to a statistician, you had better say, well, I failed to reject HO this time, rather than say, I retained HO. Okay? Right, so we've kind of got the gist, I hope, that we don't want to make a type 1 error when we are doing research. We try and minimize these at all costs. And so now I'm saying that, you're only going to accept the risk of a type 1 error as long, again, it has to be less than 5% or 1%. So the question then becomes, well, how do we know? How do we know when the risk of a type 1 error is less than whatever, 5%, 1%? And this is the short answer. The probability of making a type 1 error is less than 5% or 1%, whichever one you choose. Let's just talk about 5%. So the probability of making a type 1 error is less than 5% when the probability of our test statistic is less than 5%. Okay, and then I'm throwing in when HO is true. So I'm going to explain this last part in a minute. Just kind of block that out for a second, okay? So we're saying that the probability of a type 1 error is the same thing as the probability of the test statistic that you're going to calculate. Or more accurately, SPSS is going to calculate. Remember, every hypothesis test calculates one of these numbers. So if you want to know what your probability of a type 1 error is, you just have to figure out, well, what is the probability of this test statistic? All right, and I'm going to explain why the probability of this is the probability of making a type 1 error. I'm going to explain why those two things are the same. But of course, now we are left with the question, well, how do we actually get this test statistic? And how do we figure out the probability of this?